Good morning, everybody. Today we're going to be talking about vectors and, more importantly, operations within vectors. Just a quick note, if you hear something going on in the background, it's because my dryer is going, so hopefully that doesn't distract you too much. Knowing me, it probably distracts me more, but we'll make it through. But let's get into vectors. So a vector is basically two different elements. It has to do with how far something's traveling, or the magnitude, or the scalar. There's a few words that kind of mean the same idea. Essentially, if you ask a true mathematician, then it would probably, they're definitely going to be a little different. But those words I might use interchangeably. I shouldn't be, but just a heads up. After that, the direction you're going. So the direction, also the magnitude of that direction. You can see these as well. So these are examples of vectors. They kind of look like rays, but really they're not rays because they stop. So vector v is pointed in this direction and travels this far. And we say these with in terms of x and y. So I and j. So if I wanted to move 1, 2, 3, so this is 3. And these units can change, but if I'm using I and j, this is 3i and 2j. So vector v, often written like this, is 3i plus 2j, j. I and j just have to do with the directions. So I would be the horizontal direction, j is the vertical direction. Again, you don't have to use I and j. You could use x and y, things like that. But I will try to keep it in terms of that. Same thing with w and u. Those are all, you're going to have direction and magnitude. This basically tells you if you're going in one direction and then a second direction, how far do you have to travel to get to that spot. But when you're adding these, you're going to start with vector v. I'm going to just draw that first. Vector v is 3 right, 2 up. And if I want to add w to that, I need to start here and follow this path. So it's starting position 1, 2, 1, 2, 1, 2, 1, 2, and go there. So this is v, this is w, starting position of the first vector, ending position of the last vector is the resulting vector. So this is v plus w. Not too bad. If we wanted to write w, that is 2i and minus 2j, or plus negative 2j. So if I wanted to write this with numbers and instead, v plus w is going to be 5i Vectors make me have to think about the direction of I and j, which is not common, trust me. And then there's no vertical movement, so this would be plus 0j or just 5i. I'm going to put the 0j just so to be clear. Just to be clear though, number 1 is just asking for this portion. You wouldn't have to necessarily do this part, but my open math is going to have a much more numerical type of question, so I want to make sure that we cover this part as well. V minus w, so if you subtract a vector, you're moving in the opposite direction, essentially. So think about the radius with polar coordinates. If it's a negative radius, it moves in the opposite direction. So that just means that we're going to start here. I'm going to give myself a little bit more room. I'm going to start here, and same thing, 3 over, 2 up. This is v. This is negative w, opposite direction. And then connecting the beginning to the last function, this is v minus w. if I wanted to do v minus w here, you subtract the different the parts of the vector. So 3i minus 2i is just I. 2 minus negative 2 is positive 4j. And you could just go back and look at the resulting vector. I moved 1 over and 4 up. That's the case. So it just follows that v minus w should be I plus 4j. 2v minus w plus u. Same idea, you just have to follow along. 2v could be v plus v, so you could just do v. So I'm going to start in this corner to get there. That would be 1v and 2v. 2v. Negative w, we just did that portion, so we're going to go 1, 2 on the diagonal. That's negative w. And then plus u. U we haven't used yet, but it's over 1 up 2. Over 1 up 3, sorry. Over 1 up 3. And we connect that. So this is 2u, sorry, 2. I'm going to keep saying the wrong letter and then say sorry and correct it to the correct letter about 1,000,000 times, I think. 2v plus minus w plus u should be this vector. The path to show you that work is this path here. So you could count out how far you moved right, how much you moved up, and count that as your numerical portion. This is how to do it graphically. You can do all of these things without a graph, though, because it's just taking the components of your vector and adding or subtracting those parts, like I did here. Okay. So if you want to do it, I kind of wrote it. I just explained this how to do this with a graph. But if you want to do it without a graph, you can literally just add the components to it. I we're going to use for our lateral movement. J is our vertical movement. Positive is to the right or up, and then negative is the opposite. There's the other portion that we haven't talked about, which is the magnitude. And the magnitude is basically how long is the vector, or what's the distance that it covers. If you're following that straight line, basically the hypotenuse of these triangles that are made. So if I wanted to find the magnitude of v, I need to find this hypotenuse of this 2 by 3 triangle. So here, this is saying that the magnitude of v is 2. The magnitude of negative 4v should be the distance traveled if I traveled 4 of these. So let's just say that this is 2, 2, 2, and 2. So this would be 4v. (4v) would be 4 times 2 for a magnitude. And its direction, or sorry, it's the length of the vector. If I flip that over and went this way, I don't have enough room to show it, but if I went basically this way and did negative 4v, it's still the same distance. So the magnitude doesn't change, even depending on the direction. Direction does matter within these, obviously. Otherwise, you would end up in the complete opposite position than you need to be. But it's not going to affect magnitude. So careful there. Scalars are when you multiply everything by one number. Negative 4 here would be our scalar because we multiplied v by negative 4. And it just basically stretches everything out, or it compresses everything at the same rate. So calculating the magnitude of v, I just draw triangles. So 1, 2, let's go. So this would be 7, negative 2. This is vector v. So you just need to find the distance from point A to point B. So 7 squared plus negative 2 squared, square root of that. It's all written here, but if you didn't want to have to memorize that, it's Pythagorean theorem essentially, just using your I and j coefficients. 49 plus 4 is 53, so the magnitude of this vector is 53. Basically just a translation between triangles and vectors. Very similar ideas behind them. Alright, so for these you are trying to figure out just what the value of these things. So v plus w, if v is 2i plus 3j, w is 3i minus 4j. If I'm adding those two, I'm going to take the I values and add them. So that's 5i. 3j plus negative 4j is negative j. And you're done. So this is v plus w. V minus w is taking the i's and subtracting. Order matters here, so 2 minus 3 is negative 1. So this would be negative I. And then 3j minus negative 4j is 7j. And this is v minus w. It's still, both of these are still vectors, so careful. They're still vectors. 3v, this is a scalar. It's basically tacking on 3 v's, and you could sit there and do v plus v plus v, or you could just multiply the coefficients by 3. So this is 3 times 2 is 6i, and 3 times 3 is 9, so 9j. 3v is 6i plus 9j. 2v minus 3w is gonna, let's figure out what 2v is first, which is 4i plus 6j, and then negative 3, or you could do 3 and subtract. I'm going to do 3 of these and subtract. So 3 times 3 is 9i. Negative 4 times 3 is negative 12j. We're subtracting that. 4i minus 9i is negative 5i. 6 minus negative 12 is 18. So 2v minus 3w is negative 5i plus 18j. Magnitude of v, magnitude of w, and add them together. So we want to figure out the magnitude of v, which is the square root of 4 plus 9. Just following along this, basically taking the coefficients, squaring them, and adding them together. And then going from there. So magnitude of v is square root of 13, and you're good. W. Magnitude of w is going to be 3 squared. 3 squared plus negative 4 squared, which is square root of 25 or 5. So that means that the magnitude of v plus the magnitude of w is equal to root 13 plus 5. Be very careful, these mean different things. And it might get that clue because they are two separate problems, but it's not adding the resulting vectors or the resulting magnitudes, and that's it. You need to find what this vector is. We already did the work here, but we need to figure out what this vector is and then find the magnitude of that vector. So since we already did the work, we're finding the magnitude of 5i minus j. So that is going to be the square root of 5 squared plus the negative 1 squared. So the magnitude of v plus w is square root of 26. And if you've been distracted by the laundry machine, by my dryer, it's done. So maybe I'll be a little more clear. All right, so square root of 26 is the magnitude of v plus w. Cool. Finding the position vector between two things. So now you know the starting and ending position of these, and we're starting to use coordinates here. In all of these, we haven't really designated coordinates, so that's something to note. But basically, you're figuring out the steps it takes to get from this point to this point. And you just have to tell the person the directions. So how far do they need to move horizontally and in which direction, and then how far do they need to move vertically and in which direction. To do this, you need to subtract, or you could put these on a graph and then figure out the distance, but it's very similar to a distance formula idea behind it, but just figuring out each leg of that triangle. So following this set of directions, you're going to take x2, which is 6, subtract x1, and that should give you 7. Take y2, just ignore that, minus y1, that gives you -2. And then just tack on some i's and j's. So this vector, v is equal to 7i minus 2j. And that would tell someone that if they're starting at point 1, they need to end up at point 2. And that would be giving them the straight line or the vector connecting. Alright, so some things to note. Unit vector is just any vector whose magnitude is 1. Think about unit circles. So if you're starting at 0, 0, and you wanted to move somewhere along the circle, the unit circle, all of those have a vector of 1, or a magnitude of 1. For a non-zero vector, v, the vector u, if you did v divided by magnitude of v, is a unit vector that's in the same direction as v. Basically what that means, if I went this direction, let's say that this is a magnitude of 7, and if I divide this by 7, I have the same exact vector directionally, it's just a shorter or a smaller magnitude. Sometimes it's helpful to know to have a unit vector, but it's basically just scaling a vector so that it has a magnitude of 1. Let's see what else. If you have the angle, you can use cosine and sine. This is similar to the idea of polar coordinates, but notice that I and j aren't imaginary numbers, so it's a little bit different. It's kind of units of measurement instead. This I is not the same thing as the imaginary I. It's just telling you which direction to move in. But yeah, so it's something that might be a little confusing. Unit vector with the same direction as this, we need to know, so we have v, we need to figure out what the magnitude of v is. So taking that squared plus -3 squared, we've done this before, square root of 25, which is 5. So v divided by 5 will give us a unit vector. V divided by 5 is 4/5 I minus 3/5 j. And this is a unit vector that has the same direction as v. Alright, if the magnitude of v is 8 and alpha is 45 degrees, write a vector in the form of ai plus bj in exact values. So to do this, we need to find cosine of alpha and sine of alpha, which is √2/2. So cosine of alpha, and then the I is just there to let you know that's the direction. Sine of alpha, and again, the j is just there for direction. Our magnitude is 8, but we're using this. Cosine 45 times I plus sine of 45 times j, and swap that out with 8. Cosine of 45 is √2/2. Same thing with sine of 45. Multiply that by 8, and you get 4√2i plus 4√2j. And that is it. Okay. So a lot of it feels like this will be the theme, but a lot of grab bag ideas for the rest of the trimester. Tomorrow we're going to be using dot products, which is just using vectors and some some applications behind those vectors. So stay tuned, but I will see you next time.